Hello, folks. Welcome to Rational Science.
Hey, guys.
Hopefully, we have a good day today. Okay, so let's get started. We're going to be answering maybe some questions at the end of the show. So have your important questions ready. If they're not important, we will not touch them. Okay, and we try to get as many as we can there. Anyways, we're going to start as always with our extinction segment. Okay. Before even that, this week I had a little glitch, as a lot of you know, and this is what happened. YouTube gave me this warning, okay, and it gave me that warning in my two channels where I uploaded the same video. One channel was just a warning. The other channel was it was it's like if I got a strike because it was blocked for like 4 days. And I worked with the people at YouTube, and they said it was a glitch, and I do believe them. I think they were working to try to fix it. I mean, these are just workers, they don't care. And I think they're workers from YouTube. I don't know if they're from the community that just volunteer to help. I don't know if that's the case. I don't know who these
You mean
people
like Wikipedia or?
Well, yeah, something like that. Like there's a community of people out there that help out and counsel people and tell them about the rules and all that kind of stuff. So I don't know if it's that or people who are paid by YouTube, who come in there and really actually try to fix the problem. If they can't handle it, then they, I guess, give it to the technicians or whoever. Anyway, and some of those people, unfortunately, they're from Philippines or India, as you probably know, and they speak all this pidgin in English. It's not very good. The companies, to save money, they go outside the country and they subcontract, and maybe it's not good for these companies. I guess they're going to be moving into Chat BGT, in the future.
Chat GPT.
Yeah, what?
GPT.
GPT.
I don't know what it stands for. I know that.
But because they're gonna have the bots answer you and fix your problems, and if they can't fix it, I guess they go to
it's gonna
humans.
Be like layers of help.
They have all these layers.
I mean, they already have that over the phone.
So what was the issue about? Well, I uploaded a video that had to do with this fellow. Okay, he's a nasty guy. He's been going around causing some trouble for people. Can't even mention his name. Okay, he's a nasty guy. You can look him up. And what it was is a video that dealt with him. Okay, and it was an international conference. Conference not in Cuba or in North Korea. It was a conference in Brussels. That's a country in Europe.
Is it like Harry Potter or Voldemort? He who shall not be named?
More or less like that. Yeah, it was a European conference on this subject, and there was a doctor who just spoke his mind. But apparently his name is a bad word. You won't see him around. I couldn't find him on the internet. I can only find people who speak of him. So he's utterly censored. And in fact, he started his video by saying something like, "This has ruined my life." So, yeah, I can understand him. But when I looked around, I found Mr. Kennedy, Bobby Kennedy's son, and he's been banned since 2021 for talking about COVID. And it turns out that now they're going to allow him to come back in there. He says he's still, as far as this news came out, he was not yet officially allowed to come back into Instagram, but he was blocked for 2 years. And now it says there, as he is now an active candidate for President of the United States, we have restored access to Robert F. Kennedy Jr.'s Instagram account. Now, how's that? So if you say something nasty and they cancel your account, no problem. Just run for president and they'll restore your account. Now, how's that for a deal? Okay. So they restored his account only because he's running for president.
You don't have to win. You just have to run.
Huh?
You don't have to win. You just
No, you don't have to win. I don't. He may not even win, but I mean, all you have to do is run. Just apply and say you're a candidate for president.
Well, you heard it. Everyone who has their Instagram accounts banned, just run for president.
Run for president, and you'll be okay. And he wasn't the only one. You can see that censorship is quite widespread. Here's a lady, a Ukrainian lady here in Germany, okay, and she spoke not against disease, she spoke against the war in Ukraine. Okay, says Germany fines a woman 900 euros for saying Russian invasion of Ukraine was necessary. And I guess he takes the sides of other Russians. And I guess the Germans didn't like that very much, and so they fined her, and maybe even put her in jail or executed. I don't know what they're going to do. But yeah, there's a lot of censorship out there for different things in all these lands of freedom. So the way I look at it, all these people are no different really than North Korea or Cuba, any of those places. They're all the same. They all censor the key information. I mean, if you go out there and speak, to the ocean, they don't care. They don't. You have freedom of speech, but don't speak into a microphone that people can hear. Okay, that's the issue. Don't speak your mind. Okay, and here's another issue that came up. Remember fingernails? The guy who made a couple of videos on criticizing my theories and my approach to science, and
What happened to him?
well, you can see that he had painted fingernails, so I called them fingernails because I thought that was kind of weird in a guy. Okay, but someone pointed out that this one has gone beyond the Call of Duty, and he's transitioning. He wants to become a woman. Okay, so he's explaining that in a video if you want to see it over there. Anyways, he's transitioning, means he's trying to become a woman. He's essentially come out of the closet. Okay, a lot of people doing that these days, or at least it's heavily in the news. Okay, so what do you think of that? Okay, I don't know. We live in strange times, or we can say, what is it? Queer times.
Doesn't even phase me anymore.
Yeah, yeah. There's so much news. It's unbelievable. Okay, I say that this has to do with this loss of genetic diversity over the centuries. Okay, I think a species can only lose genetic diversity. It gains it at the beginning, then it starts losing it. And even though we have mutations, constant mutations in the population, it's the founder's effects, the population bottlenecks that overrule that.
What? You made a quick jump there. Why are we talking about this all of a sudden?
Well, because I'm saying that that's the preamble. Now I'm going to tell you why. Why I'm mentioning that. I'm saying genetic diversity, the fact that we lost our genetic diversity, is the cause. Is the cause of why we have these situations today of people transitioning and coming out of the closet and so on. Okay, so that's what it's got to do with. And here we have an example of that. Mr. Calhoun, he produced homosexuality in the lab. Okay, and here are his mice, famous experiment, especially Utopian Universe number 25. He did many of those over a 30-year period. Okay, he started in 1947, 1948, and ended up in like I think 1975. So he was doing all these experiments first with rats, then with mice, almost every year, every 2 years. Okay, and so what happened? Well, here you can see the chart. Okay, let me remove this one here. Here you can see the chart, and you can see what's happening to the population of mice. He started out with the grandfathers, the seed, okay, and there were 4 pairs of mice. They were normal mice in the sense that the males got a hold of the females, they made their nest, and they started procreating. Normal stuff, right? But then after 2,200 mice, protected against all disease, they had all the food and water they wanted. They had all the nesting material they wanted. The only issue was space, okay? And the fact that they all descended from the same grandparents. That's an important one also. And you have to remember also that these mice were not field mice. They were mice that they got from a laboratory, which already had their genes, washed out over the centuries. And this was their starting seed. And you can see what's happening there. The mice multiply and then they go into extinction. But before they get to extinction, a lot of them become what? Autistic and homosexual. So something affected their brains. to the point that Mr. Calhoun said they are no longer mice. And he said he was a psychologist, so he was looking at it from a mental point of view, and he said that humans are following the same footsteps. And Mr. Calhoun died, but I think he would have seen that what he said is quite true. It happened,
I
that's what
still
we're
don't
seeing
think it
around.
has to do with genetic diversity, though.
I think it's got a lot to do with it because of this. Look, let me give you another example.
That's
Okay?
a place where we disagree a lot.
Yeah, I know we disagree on that, but this is the issue. This is the way I look at it. I was 9 years old and I fell in love with a girl next door. Okay, 9 years old, damn, and she was 6 years old. And I wasn't the only guy. I had my next door neighbor and another guy down the street. The next door neighbor was 9, just like me, and the other guy was only 7. All three of us were head over heels over this girl. Okay, she was just a knockout. She was a beautiful. She was a doll. Okay, and it wasn't like my father and my mother said, "Hey, Bill, you got to look at girls, not at boys." That never happened. It's like nature called. Okay, and when I was around 11, I fell in love with my English teacher. She was my homeroom teacher, and so these are things that are in nature. You're born with it. No one teaches you these things. You have the call of the wild, so to speak. And so isn't that genes? Isn't that you? Isn't that nature? I mean, that's the way I look at it primarily. I think, in other words, if I had to judge this guy, which I don't, I mean, it's his problem, but I mean, I think he was born that way. Okay, it's not that he was educated by his parents to be that way, or by school system, or by peer pressure. He's already been born that way. He can't do anything about it. That's the way I look at it. Okay, and I think it's got to do with the fact that humans have washed their genes, their pool, their genetic pool over the centuries. And it happens to all species, I think, and with different results. Not all of them become homosexual and autistic, but there you see the experiment by Mr. Calhoun with mice, and it does happen. I've also read about, there's quite a bit of material about sheep. 10% of the sheep are homosexual, okay, and you can look that up. And lions, you'll see lion mounting lion. Hopefully they weren't taught that in school.
Well, since I think it has to do with the density, right?
Okay, to some degree.
One
Yeah.
question I would have is, there's that phenomena where animals who end up on an island end up shrinking.
Yeah.
Insular dwarfism or something
Yeah,
like
yeah,
that.
it's a
Really
dwarfism,
weird.
correct.
But since they're on an island, don't they have the same circumstances as the Calhoun mice?
Well,
So couldn't we test it?
in those situations, what you'll notice is that the density is very low. So there's insular dwarfism, but
Is
and
it
to some
is
degree
it
is
held
related
back
then.
by the food chain? Or
Well,
what's
there's
the...
density dependent birth rates, and it has to do with crowdedness. So the fact that we humans are crowding into cities, that's very likely
No,
to
but I'm
some
talking
degree a
about
cause.
specifically the insular dwarfism.
Yeah,
When a species ends up isolated on an island,
yeah.
do they not experience the same Calhoun mice fate because of other circumstances? Because
Well,
isn't that essentially the same?
yeah, but then I think what you have
Would they
to
all turn gay?
what you have to look at there is that animal, that species.
Yeah.
Where is it in its history, in its development? Because
Well, no. That's not. You're talking about. I'm asking, like, did that happen? I'm not saying.
well, I'm not sure anybody when they investigate insular dwarfism, what they see is smaller elephants, for example, right? That's happened, and maybe that happened also to the Florensis. Florensis man was they found over there in the Philippines in an island. They're small, and so one of the theories that maybe insular dwarfism affected them. But the issue here is, in all these cases, nobody really investigated if there was any homosexuality among the elephants or among the Florenses. That's one issue. The other issue is that when they got there, there were relatively few of these animals, few elephants, few Florenses. Okay, they only found, I think, 6 of them or 8, something like that. There's been no real study because it's not like a widespread phenomenon. Okay, that's one issue. The other one is the one I raise is that over the centuries, you lose genetic diversity, but not all species lose that genetic diversity at the same pace. We come from the same stock maybe as the chimps. Okay, we somewhere we in the past we meet. Okay, we had a one grandfather or grandmother somewhere out there, and and chimps today have more genetic diversity among 100 chimps in a troop than the entire human race. And part of the reason I think is they don't have density at this point. They have all the space they want. That's one issue. But the other one is that maybe you got to look at it in their evolution.
Yeah.
Where they are, where their genetic diversity stands in their history. And they're more primitive maybe, and we're much more advanced. That's why we've got all our genes washed up. But yeah, anyone who you marry today is your brother or your sister from a genetic point of view. That's my theory. Okay, let's move on here. We have this, which came out in the news this week. Scientists discover a virgin birth in a crocodile. Now, this happens in other animals that I've heard about, and there you see it. Baby croc was a parthenogen, the product of a virgin birth. Okay, so yeah, this croc did it all by herself. Okay, and there you see at the bottom it explains how that happens. Here's how a virgin birth happens. As an egg cell matures in a mother's body, it divides repeatedly to generate a final product with exactly half the genes needed for an individual. Three smaller cellular sacs containing chromosomes known as polar bodies are formed as byproducts. Polar bodies usually wither away, but in vertebrates that can perform parthenogenesis, one polar body sometimes fuses with the egg, creating a cell with a necessary complement of chromosomes to form an individual. So some animals have the ability to produce, children without the male. Okay, there's a female does it all by herself, and it happened to us also. I think with Mary and the archangel, he came through a window, a bearded guy, and then left through the same window when her husband appeared. So yeah, we have virgin births as well in humanity, I guess. Right?
Happened once.
Yep.
Happen again.
Yep. That's what the women tell their husbands.
Yeah.
Why this guy come black if you're white? Well, virgin birth. Okay. Okay, and then other great news involving extinction. Here we have people who are searching the skies for extraterrestrial intelligence. Sometimes I think they should point their telescopes to SETI or to search for extraterrestrial intelligence, or to Cambridge University, finding out if there's any intelligence there.
Hold on. Still on the crocodile, right?
You're still on the croc. Okay, yeah.
Aren't crocodiles a really old species?
Yes and no. Where are they in their evolution?
But I thought, according to biologists and anthropology, that they're one of the oldest things. Them and sharks.
Sharks and crocs are not old.
No.
Let's put that on the table, because people make a lot of mistakes there, and they just take bits and pieces and they say, oh, you have the lungfish today, and they say, oh, that dates all the way to, I don't know, Devonian or whatever. Yeah. Not true. The animals over there is like a Neanderthal to us. I'm sure that if a lungfish today saw one of those lungfish of those days, he'd run the other direction, especially if he meets them in a dark alley.
But then isn't it?
So the sharks and the crocs have not been around since the Cretaceous. Okay, we had different species. They all look the same, But if I take a shark today or a croc today, and I compare it against a shark or a croc of the days right after the Cretaceous collapse, Cretaceous tertiary extinction there, 65 million years ago, they're not even similar. They're two different animals, two different species. That's what I mean. They wouldn't be able to have babies together.
Yeah. But are their genes also washed up? Because they might have birth defects like crocs with two heads and shit.
Well, I don't know about crocs with two heads. That might even happen. Don't put it past them. But there's animals that had two heads. Among them humans. Human animals.
Well, yeah, but we're washed up, is what you're saying. You're saying the reason that happens but you always use it in a retrospect. You always use it as like a ad hoc, like, oh, if anyone has a birth defect, their genes must be washed up.
Good. That's good.
But you don't, you do it, but there's no way of, you're kind of just using it as a band-aid.
Well, what I'm saying is, at least we got to look at that. I think genes have something to do with it. That's
Well,
my
yeah.
main point. And I've talked about peaches. The
Yeah.
peaches a couple thousand years ago, they were like berries, and we selectively bred them. Over the centuries, and we always pick the big ones. And today you have a peach that's this big, and that's not the peach that was there 2,000 years ago. And I planted a peach tree, in my garden, and there were 5 instances, 5 peaches that came out of that peach tree that were Siamese twins, two-headed peaches. And I'm saying that it's got something to do with the fact that peach tree, has suffered an evolution to the point that today they have their genes washed up. And so, yeah, now we're having two-headed peaches, and it's not the only veggie or the only fruit out there that has, two-headed things. So I think it's got something to do with genetics. I don't think they went to school and say, I'm going to have two heads. This is something that has to do with genes. That's the way I look at it primarily. Okay, let me get on to SETI
Yeah,
here.
so what's
And
going on with Teddy?
they said SETI is the search for extraterrestrial intelligence. I think they're in
Is that still
California.
going on?
Yeah. They have all these listening posts. They want to listen to what is it, to signals coming from outside
Radio
the Earth.
waves is what
Yeah,
they're looking
or
for.
whatever they can hear. Maybe they get some electronic waves, electromagnetic waves,
Well, that's what they say.
or
Is
sound waves.
that we're not going to see them. The first thing we'll probably see is the radio waves, because that.
Yeah, and some people say, "No, Bill, they are here." Okay. So here we have the news, is it the
Headline.
headline? Repeated signals from the center of the Milky Way could be aliens saying hello. New study claims, right? And so they go through this, and the question is whether this has anything to do with science or reality. Okay, whether there's anything out there that has contacted us. And one fellow says, "Hey, they're already here." Okay, and I think they're all in Cambridge University. Okay, but that's this fellow here. Okay, and he says that his name is David Grush, and he says that he's convinced, he knows, he's got the inside scoop that the aliens have come to Earth, and it's just being hidden from you because the government, is trying to prevent you from knowing this information. You might panic. That's the rationale behind it. Or maybe it's got to do with national security, and that's why they're withholding this information, right? So here's the news. Says David Grush. He worked as an unidentified aerial phenomena task force with top clearance levels. So they're saying he's not just a nobody. He's a guy who's worked out there in the. He had the inside scoop. He worked inside the government. What did he work on? Extraterrestrial stuff. So that doesn't strike me as strange. He works in this, and then he comes out saying, "Oh yes, we know they're there," and he says it's kept hidden from the American people. And what is kept hidden? Well, he says exotic origin of non-human intelligence. Okay, so he's saying that all this stuff, he says they recovered an intact and partially intact vehicles of non-human origin. And so the first question we have to ask is whether this is another move by the U.S. government to, like Assange and Snowden, to fool people into believing that these people are real.
That's the first thing we gotta ask.
Yeah, we have to ask.
That's the first thing. I got like 5 questions before that.
No, that's the first one.
Why is that the first one?
Because
why is the first thing you think of?
Okay,
the government is trying to convince people of BS, essentially.
Well, because this guy comes from the government. That's the first one. He comes out. He's allowed to put classified information in the public domain, and the government doesn't execute him or torture him or anything. That's weird. I mean, the first thing the U.S. government would do is Stop this guy from. I mean, he's still in the U.S. It's not like he ran like Snowden
Oh,
first to China and then to Russia or what's his name?
tell me when you're done, because I got a counter argument.
Okay, go.
I'm the U.S. government, right?
You are.
And
Well, you are. You were born in Austin.
Let's even assume. What are we assuming? That they know that there are that, like, if you have a guy saying that there's aliens, if you shut him up after he already said it, it would give weight to what he's saying.
Wrong.
No?
You don't let him talk.
Well,
you don't wait till he goes out there.
You make it sound like they have that much control.
They do.
What?
Oh, yes, they do. Oh, I mean, if he goes to a newspaper, okay, who runs the newspapers? Well, we know who owns all the newspapers in the United States, right? So you go there and you say, hey, I want to print this. I just took it out of the government. It's classified information. I want you to print it. Oh, yeah.
Well, yeah, it depends on where you printed it. Wherever it was
oh, Washington Post, maybe New York Times. I don't know. One of those unknown places. Yeah, they're going to stop you immediately. And in fact, they're going to call the U.S. government. And usually go through Assange or through Snowden, they'll call the U.S. government and say, hey, there's this buddy who's trying to get in touch with me.
Can I just ask, why does the government care about telling us that there are aliens?
Good question. Why? Why did they throw gas in the fire with flat earthers? I mean, flat Earth is also a U.S. government-run operation that has expanded. Why? Who would believe in the flat Earth today? I mean, yeah. You see,
completely losing me. What?
Flat
Earth is a government conspiracy now?
Well, I think they're.
How deep in the rabbit hole are you?
No, hold it.
I thought we were the rational ones. What?
Listen, there's a group of people and they say flat Earth. Okay, great. Now, suddenly more people start believing that, and that's when, they're infiltrated. But they're all these organizations, when they start growing, they're always, 150% always infiltrated. The Ku Klux Klan, you name it.
Ku Klux Klan I can understand because they're killing people.
No, Who
cares about flat Earth?
Because they need to steer. It's steering.
Steer what?
And when you see
that, give me it from the government's perspective. Why would they want to?
When you have thousands and then hundreds of thousands, then millions of people believing in something, the U.S. government wants to get in there to steer that in the direction that they wish it to be steered. Always. Flat Earth.
No, don't make a list. Don't make a list.
Oh,
flat Earth?
Yeah. All the way.
What the fuck?
They steer. They just they don't
care.
Yeah, okay. They don't care what you believe in. They just steer people and they say, okay, there's a million people who are flat earthers. No problem. Let's steer them in this direction.
So you're saying you have a lot of people that believe one thing, so it's essentially like a cult.
Yeah.
And since it's a cult, they can be, you can say, organized.
They
can
manipulate.
Not just manipulated, but you're saying they can be manipulated as a group to do other things that have nothing to do with flat Earth. Is that what you're saying?
You don't think religion? Yeah, I'm talking about some of these people who go out there like this fellow who died the other day. Forgot his name now. And they have all these religions, and there's millions of people who pay attention to these religions. You don't think they're infiltrated?
Well, yeah, but so.
What I'm saying is you have listening. That's one issue. They need to listen. What's going on in there? That's one issue. They may not have to do anything. They just send someone in there and listen. And then if they need to steer that, they will work from the inside. If it's an important organization, they will try to steer it.
Somehow I doubt the human governments are that organized.
The U.S. government spends $92 billion on intelligence. And you would say, well, we have the Russians and the Chinese. No, that's 10 cents. The infiltration is to steer the U.S. people, the American people. Assange and Snowden are there to steer the American people. They're not there to fight against Russia or China.
Yeah, that I can understand.
Why did China get rid of Snowden and said, get out of here? He was there 3 days, and they said, well, you got 72 hours to get out of here. Yeah. And he went to Russia. And why did Russia accept him? Because he's not spying against Russia. He's spying against the American people. He's the leader of the Contras of the United States.
But that's WikiLeaks and spy shit.
Yeah.
But
it's steering. No, but it's steering.
But
because, these people are there now, and now they can orient you and say,
But flat Earth?
Flat Earth is a similar thing. It's a similar notion. Imagine you have thousands, then 100,000, then 1,000,000 people. You say, well, look, there's a growing movement,
Okay.
grassroots movement,
Yeah.
and we want to take it in the right direction. The NAACP, another organization, well, take it in the right direction. You know, maybe they need to steer, maybe they don't, maybe it steers all by itself. They need a listening post in there. How do they catch drug traffickers? Always they send someone inside.
Yeah, but that's drug
Always.
trafficking. But
Oh,
flat
okay. Yeah,
earthers?
what? How many lists?
Flat yeah, the list ends before flat earthers
No,
and aliens. Like
no, no.
you think they're going out having a dude like hiring a guy to spread false information about aliens. You think like okay, I know that they're wasting a lot of money, but Jesus Christ, that's a lot of taxpayers' money.
Well, I mean, it depends on what they need for you to believe. At some point, they need maybe for you to believe in flying saucers. Another time, they need for you to believe in the flat Earth. You know, so it depends on what how they want to steer you. Okay, so they put out what fake news, or you know, or orient the organization from the inside.
I
You know,
highly doubt they think that they can steer uh non sorry people who are I want to say not beyond the pale but like conspiracy theorists.
yeah.
Can you really steer them much? They like
Yeah, those are the. I mean, a lot of people who were 9/11 deny. You know, they didn't believe the official story from 9/11,
yeah.
and then they follow Snowden, and they follow Assange. So the U.S. government says, "Oh, we didn't get you there. We got you now. We got you anyways."
But aliens though, that's where it's like, geez.
Well, tomorrow they might need the information. They might say, you know, there's a war in Ukraine, and maybe Ukraine loses. Say, hey, look at the flying saucers. We have these extraterrestrials coming, and so people forget about Ukraine and start thinking about that. I mean, it's the way you manipulate the information. Anyways, here's why we don't have extraterrestrials here like this fellow Grunch says. Okay, here's the linear regime according to the rope hypothesis, and any vehicle trying to leave the bird's beak, and here you'll see it from the start. Hold on. There's the bird's beak from our sun. Okay, and if you try to leave the bird's beak, you know that have all the ropes that are connecting every atom of the Earth to every atom of Alpha Centauri, for example, right? If you try to leave that birth peak, you enter a linear regime where gravity is not the same, doesn't work the same way as it does here on Earth. Okay, and all you'll see for eons is, just going right through the ropes. You're just sliding through the ropes there, and you will not be sliding at the same speed as you would, thinking that you're going to be attracted by Alpha Centauri at the same rate you are here. No, you won't. Once you enter the linear regime, you're going very, very slowly forever.
Why slowly though?
Well, because you don't have see.
No, keep the picture.
You need that. You need that. See, that's.
But doesn't the bird's beak hold you back?
Well, it's a long story. You got to look at my video. I just don't want to get into it because it's. You need a long explanation for that. Okay, but my point here is there's a linear regime between two balls. Okay, you have two balls, right? And imagine they're connected. Okay, like there. Let's see. Like so. Okay.
Wear blue shirts so you can be seen.
Okay. Yeah. There. Okay. So they're connected. Okay. And so what happens if you're trying to get out of here? Here, in close to the ball, you're going to have this bird's beak, and within the bird's beak, you have Newton's gravitational equation. But when you get to the long linear regime, at that point you travel slowly because there is no attraction from Alpha Centauri or from the sun, for that matter.
You sure you don't want to get into it?
No, it's too much. It's too late. I've got a video. Look at Pioneer Anomaly, and
I thought I was here to get into something.
Well, otherwise we're going to spend all night here with this one.
I got nothing.
Okay, so here's the final issue. China edging out Russia on sanctions to redraw Kazakhstan trade. You have all these countries. They're the stans. Kazakhstan, Kyrgyzstan, Uzbekistan, and so on. And people say, are these countries that belong here on Earth? And here's the map, okay, so that you can put in the right context. And you can see put the populations in each one, and that's that region between Russia and China. Russia has 100 million more people than Ukraine, but China has 10 times more people than Russia. And what's happening now is those countries that used to be part of the Soviet Union, in other words, they were governed from Moscow, no longer are. And what happens is Russia still maintained quite a bit of commerce with them, but China is now muscling Russia aside and taking over. The country that's not involved there very much is the United States, or Europe for that matter. Now those have much influence in that region, and China is now kind of muscling Russia aside. Keep that in mind because this war in Ukraine has got Russia busy with what's going on over there on its eastern border, and here you have China muscling in their own territory, trying to conquer some of these countries through commerce. And there you can see the how China is having some inroads into those countries. The black is the China, and orange one is Russia. You can see how slowly the Chinese are muscling the Russians aside. So that's going to have an impact in the next few years. Okay, keep that in mind. Okay, so I thought I'd mention that as well. Okay, let's move on to the subject matter today.
Oh shit.
Okay, yeah, we get there.
Subject.
Yeah. Subject. What is the subject? I don't know what the subject is. What is the subject? Subject is there such a thing as the fourth dimension? Well, that was the Twilight Zone. Is this the same thing? Four-dimensional? I mean, can you even imagine the fourth dimension?
Yeah, true. You can imagine the Twilight Zone.
Well, it depends on how many beers you had. I mean.
No, I mean the Twilight Zone. You can imagine. They show it to you. It's a video.
Okay, so
fourth dimension, no.
No. Well, we're gonna start this segment with a fellow who asked a question or made a comment. Okay, so we'll go with this comment first. Here it is. First fellow says, check 3D toilet paper sheet. Remove one dimension. Okay.
What?
If its thickness, it does not turn into 2D or a 1D. It turns into 0D. Okay. So you got 0D and 3D in the real world. So he's saying, look, you take toilet paper, right? It's 3D, right? You remove one of the dimensions, whichever one you want. And he says remove thickness, for example. Okay? He says you don't end up with 2D, the other two dimensions. You end up with 0D because there's nothing there anymore, just by removing one dimension. It's no kidding.
What?
So 3D minus 1D is not 2D. 3D minus 1D is 0D, he says. Now, it took him a long time. I think he deserves a Nobel Prize. Okay, that's what I think. Okay? 3D minus 1D, that's new math.
You lost me.
3D minus 1D is equal to 0D, not to 2D. Okay. Same fellow, he says the following. He kind of laughs a little bit. He says, number of numbers, referring to the definition of dimension. Okay. And he grins. Okay. Yeah, if you look up the word dimension, okay, at least Wikipedia, you can look up anywhere really, the minimum number of coordinates, that's the definition.
For what?
For dimension.
No, but the minimum number of coordinates for?
No, just the minimum number of coordinates, blah, blah, blah.
Minimum number of coordinates.
It doesn't matter what comes after that coordinate.
That's
words.
the important part, isn't it?
No, this is the important part because they're defining what it is. It says number of coordinates. So what is a coordinate? It's a number. So we have the number of numbers, so he's laughing at himself. He doesn't realize that those are the definitions that the mathematicians work with.
Well, yeah.
In mathematics, a dimension is a number line.
Yeah.
Just numbers. So it is the number of numbers. That's what a coordinate, what a dimension is.
Does a line give it a direction already?
No, that's the point. The point is, I discussed that last week.
10 is after 8.
Yeah, but it's not.
Going in that direction?
But it's not. See, this is the point. That's not a direction. Numbers have no direction. I can put a number.
No, but a number line.
Yeah, but that's why they put it on a number line to give you the sense of direction when numbers have no direction. It makes no sense to put numbers in a given direction.
Okay, yeah.
That's the issue.
Because you can just as well flip them.
Yeah, or you can put them like I did the other day. I put them in different orders.
Yeah.
Like a 3 over here, a 4 over here. Are you going to hold it against me? I mean, there's no direction to numbers. And the point here is that the dimensions of math are not the same as the dimensions of physics, which are length, width, and height. So when they talk about dimensions, they're not talking about length, width, and height, at least not always. This is more or less like the dichotomy between weight and mass. Mass is sometimes weight and sometimes it ain't. Sometimes it's quantity of matter and sometimes it's how it presses up against the scale.
Yeah.
And when they want to use one notion, they use that one. When they use the other one, they use the other one. Nobody notices the difference because they always use the word mass. And this is something similar. Here they say, look, a dimension. And you say, well, are you talking about length, width, or height? No, I'm talking about all those numbers on the line. So you're not talking about dimensions of physics, but they use it in both senses. They say, well, it's this and it's also this. So they cover all the bases and they think they're doing physics, mathematical physics, because they're putting numbers underneath length or width or height.
I mean, sometimes they also say temperature is a number, is a dimension.
Yeah, and they have all these dimensions.
Once you say temperature is a dimension, then we got a problem because, I mean, it's the same problem as time being a dimension, where it's like,
right.
People say we live in a 4D universe, but it's like, well, are you counting temperature? Then it'd be 5D. Are you counting the imaginary number line I came up with?
And that's exactly how they do it. They say, look, it's a dimension of laughing.
Yeah. Because
what is that? What do you mean the dimension?
Forget 3 and 4 or 5 dimensions. There's as many as you can come up with.
And here it is.
And then the word just becomes meaningless at that point.
And here it is, okay? We started with the universal movie, and we're saying first that we're going to put number line, and vector in the dynamic region, and dimension and coordinate in the static region. What is static? What is the universal movie? Well, a single frame only represents static concepts. And if you need at least 2 frames, as all those at the bottom, or more, you're gonna have dynamic concepts. Why? Because as you can see, the word number right there at the bottom is the verb to count. That's what it means. That's what the word number stands for. Number is the verb to count. Numeral is the symbol you use to represent counting. Okay, and number line and vector are both dynamic concepts. Vector is a dynamic concept because it's displacement. Okay. Vector is what? Magnitude and direction. Yeah. Direction of what? What do you mean numbers go in a given direction? Magnitudes go in a different direction? No, what it is that they say, look, here's A, we put an arrow to B, and something moved from A to B. But what they want to do is put some numbers here so they can say at what speed or what rate or whatever A went to B, or how much distance it covered or whatever. So a vector represents motion, always. That's why they would say magnitude and direction. But see, the word direction doesn't belong in math. You can't add directions. You can't subtract direction, multiplying. Direction is a word that belongs in physics exclusively, not in math at all. Okay, and this is where the problem is. They say magnitude and direction, the vector belongs to math. No, vector is one thing which it belongs to physics. And what belongs in math is the number line, which has nothing at all to do with direction. Number lines don't have directions, except in math.
We have our first question. How many dimensions does the flat Earth have?
Good question. It's the same question we addressed some time back. Yeah, it's not that.
It's like when I asked him
how flat is flat. And so if it's completely flat, it's like this guy says. You subtracted one dimension, you ended up with 0 dimensions. Okay, that's. But how flat is flat, and they always show it as a pancake, not as a flat. So it's not a flat Earth; it's a pancake Earth.
It's the 2-inch,
and it's resting on turtles.
Yeah, turtles are flat.
All the way down.
How flat is flat?
Okay, so here's the recap for that. Okay, we have numbers. Number lines and vectors, they are dynamic concepts, whereas dimensions and coordinates are static concepts. In math, dimension coordinates equal number lines. Okay, that's what they mean when they say coordinate or dimension. They're talking about number lines. Number line lacks direction. Number line has no reason to have any direction whatsoever. You don't put numbers in a given order except, to organize it for someone, but to actually think that numbers have direction is what's irrational.
Well, I think the irrational part is already the term number line.
Yeah,
line.
Line. The word line should not be in there. Okay? In fact, the word line does not belong in math either, because line and point, assuming it's a dot, right? They belong to physics. Those are objects.
Well, it depends on what line we're talking about.
Well, but
if we're using the
what I'm saying
conceptual one, then I guess you could put a floating number line there. Like
Yeah,
we
but I'm
use a
saying
ruler.
line
Yeah,
is you
line.
cannot add or subtract lines.
Yeah, that's true.
It makes no
Well,
sense.
it
It
does,
doesn't
but it would
belong.
mean something else. It'd be like pickup sticks, lines.
But see, this is words that represent objects do not belong in math at all. You can't add or subtract tables.
Yeah.
Table minus table. You can add, you can subtract 1 minus 1, but not table minus table. You cannot subtract objects or tree from a table or whatever. Wood. Okay, and so number line lacks direction. Okay, therefore, infinite.
The
Number
famous
line is
infinite.
infinite. Yeah, you can count forever. That's what infinite means, really, in math. Number lines. You can put, like you were saying a minute ago, that you have all these number lines, and if a number line is, temperature or time, you can put a million of them. You can have the dimension of intelligence or whatever. Whatever you want. In math, 4D is equal to number lines. That's what they say when they say something is four-dimensional. They're saying it's four number lined. Okay, that's what they mean. So when you see the tesseract there, tesseract is not four-dimensional. They're saying it's four number lined. Okay, that's what it's all about.
But what about temperature?
Well, the same thing. It's number lined.
But it's missing there. That's right.
Well,
Could be
there's
more dimensions then.
Well, yeah, I could
What
add
about
a million.
what about color dimension?
Well,
what
no,
about
the reason
size dimension? What about
no, the reason I put only that number line, right? Because the tesseract is allegedly an object that has length, width, and height that is growing, that is expanding.
Yeah.
That's what a tesseract is supposed to be. So what is it expanding through? The dimension of time, they say. That's you can see.
Sound so complicated.
Yeah, see, so it's all what they're talking about is number lines. They're saying we're going to use these numbers in our calculations, and we're going to call that result a tesseract. And they sneak it in there saying it's got length, width, and height. It's a cube, right? And you say, okay, I understand that.
So
it's
far,
a cube.
so good.
But what they're really representing is each one of those, length, width, and height. They're replacing them with number lines that have direction, and then they have this thing that has direction already, and now they're going to expand this moving object, this cube, right? They're going to expand it through time, which is that corner number line, right? And that's how you build the tesseract. So this is a moving object. This is not an object. This is an object that is expanding and it's moving through time. I guess I don't know how. This is how they handle it in math. Okay, but it has nothing to do with physics. This is not a physical object. Okay, and again, you can see the math number lines have nothing to do with the dimensions of physics. They also have nothing to do with the coordinates or vectors of physics. Okay, so what do we have? We have length, width, and height are the dimensions. Physics. Coordinates are a way of locating an object with respect to other three reference points, which are at 90 degrees to each other, perpendicular to each other, orthogonal. And so what you have is altitude, latitude, and what's the other one? Longitude, latitude, and altitude. Yeah. And then vectors are depth, breadth, and elevation, because you're having motion. Depth, going deep, right? Breadth, sideways motion, and elevation, upwards motion. Okay? So those are the vectors that belong exclusively to physics. In math, none of those have any relevance. What they look at in math are number lines. And that's where people get confused, because are we talking about dimensions or are we talking about number lines? That's what you got to keep in mind. And here we have some questions for you, okay, for you to ponder today. Okay, we have these questions. Is there such a thing as the 4D, fourth dimension? Is there any object that is four-dimensional? Can you imagine any object that is 4D? If so, please draw it, and we'd like to see it.
No, you can't draw it. You can only imagine it.
Well,
I have it in my head, but I can't show you.
Cheating.
That's how I do that.
Yeah, put your head, give us a piece of your brain, your mind. Okay, is there an entity that is 10-dimensional, as string theory alleges? Okay,
10-dimensional. I can come up with way more than that.
Depends on how many beers you drink.
No,
or whiskeys.
Off the top of my head, I can already come up with more.
And there you see my 16-dimensional universe. Okay, is that possible? Is that what you're staring at there? Is that a 16-dimensional universe? Or is it just a bunch of lines on a flat surface?
You're missing temperature, color.
Well, you can put anything you want in those. Like you say, you call it anything you want.
It's ridiculous.
Yeah, but here it is. Here we have the people in mathematical physics. They're going to put you straight. They're going to tell you exactly how they visualize dimensions. Okay, this is what this is about. Okay, can you visualize? Can you see? Are there such things as 4D and upwards? And here we have our first witness. This is what he's going to tell us. This is Mr. Stephen Hawking. He says, it is often helpful to think of the four coordinates. Look at his language, okay? Four coordinates of an event as specifying its position in a four-dimensional space. Coordinates in dimensional? He's mixing coordinates with his dimensions there. Called space-time. It is impossible to imagine a four-dimensional space.
It's easy.
Okay? No, but I mean, if this is the guru, right? I mean, if he's telling you how it is, you got to accept it, on the basis of authority. So he's saying you cannot imagine the 4D. Okay, that's our first witness. Okay, now we have another one. Here's good old Einie, okay, and this comes out of the Wikipedia. And what does he say? He went on to the other side. Give me a second here. Get it back in there. Okay, so it says, in everyday life, there are three familiar dimensions, 3D of space, weight, height, width, and length. Einstein's general theory of relativity treats time as a dimension on par with the three spatial dimensions.
I like that. Spatial dimensions.
Yeah, spatial.
Also known as dimensions.
The spatial dimensions. In general relativity, space and time are not modeled as separate entities, but are instead unified to a four-dimensional. So they're treating time as a dimension, right? So yeah, you're right. Why do they say 3D when it's 4D, right? They're all the same. In fact, Hawking tells us there's no difference between the time dimension and the space dimension.
But then why would he make a difference for the temperature dimension?
Yeah, ask him. He's dead.
I'd love to ask whoever.
Yeah, but he's up there in heaven or hell. Yeah.
It's just really that they don't need it. That's all they say.
Says, in this framework, the phenomenon of gravity is viewed as a consequence of the geometry of space-time. But then on the right-hand side there, you see all the string theorists, okay? And they say something different. They say, in spite of the fact that the universe is well described by 4D space-time, there exist scenarios in which there could actually be more than 4D than the four dimensions of space-time, which have nonetheless managed to escape detection. So we cannot detect these dimensions, okay? That's what these people say. These are the string theorists, okay? And they're trying to unify quantum with relativity. That's what their business is. That's what their job is. Here they are again. So string theories require extra dimensions of space-time. So they can't just live with general relativity at its four lousy dimensions. They need to have a lot more. Okay.
We're just talking about locating something, right?
Well, let's find out. Let's find out what these people tell us. Says, for their mathematical consistency, in bosonic string theory, space-time is 26-dimensional, while in superstring theory, it is 10-dimensional, and in M theory, it is 11-dimensional.
Did you ever look up what these dimensions are exactly?
Well, I wish they would name them so we knew what they
don't
are.
name them?
No, of course not. They just say, because they're talking about number lines. They're not dealing with dimensions at all, but they call them dimensions. And that's what confuses people. They're talking about number lines. In order to describe real physical phenomena, using string theory, one must therefore imagine scenarios in which these extra dimensions would not be observed in experiments.
What?
So you can't detect them through experiments, but they're out there. Kind of fishy. It's like saying, we know they're there, we're the mathematicians, you got to believe us, but we can't find them even through experiments.
Well, I mean, for fairness, we say the same thing with the ropes, right?
Yeah, but see, this is the issue. We're not asking people to believe. We're saying, look, we're going to make an assumption that there are ropes out there, right? This is not what these people are saying. They're saying, we proved it. We know. We certify it.
That's where they cross over.
And why can't we see them? Well, it's called compactification. That's why we can't see them or detect them with experiments, is one way of modifying the number of dimensions in a physical theory. In compactification, some of the extra dimensions are assumed to close up on themselves to form circles. We have curved dimensions here, right? If the hose, listen to this is the example they give. If the hose is viewed from a sufficient distance, it appears to have only one dimension, its length. If you can see it from anywhere, it's got at least two dimensions, but they say it's got only one dimension, and that's length. Okay, we'll accept that for the moment. However, as one approaches the hose, one discovers that it contains a second dimension, its circumference. So circumference is now a 2D dimension, a two-dimensional thing, right? Thus, an ant crawling on the surface of the hose would move in 2 dimensions. So they're talking about moving in 2 dimensions. I thought motion had to do with vectors, but here they're saying it's dimensions. And this is the punchline here, okay? Here's these fine gentlemen. They say, in physics, string theory is a theoretical framework in which the point-like particles of particle physics are replaced by one-dimensional objects called strings. So the string is one-dimensional. And the question is, what dimension does it have? Length, width, or height?
Numbers.
Well, yeah, numbers. That's what they're talking about. Okay, they're not talking about dimensions at all. Okay, and they call them strings. Okay, and string theory describes how these strings propagate through space. So we have one-dimensional strings, which no one can imagine. We cannot imagine a 0 or a 1-dimensional or a 4-dimensional string.
You're saying they're not skinny. They are literally one dimension.
Yeah, because they're talking about number lines. They're not talking about dimensions. So they say, look, we have all these
we
numbers.
We don't need length with the height. We don't even need to imagine it. Just,
right.
We just care about the number line, right? Forget the but they're giving a dimension to the number line.
Yeah, but listen.
That's what I get. Hold on. Can I just really quick interject?
Yeah.
This string that they're talking about has one dimension, right? Or they say it like that. But aren't they just saying that they're only using one number line because that's all they need?
Exactly.
So why call it a string? Why call it a dimension? Why give it all these things?
Because the word string immediately takes it into physics.
Yeah, that's the bottom.
So it's misleading to say string because people imagine, this is a string. People say, okay, I understand what a string is. Here it is in black, right? I know what a string is. It looks something like that, right? So people say, okay, I know what string is. What you're staring at is not one-dimensional because otherwise you couldn't see it, okay? It's at least two-dimensional, right? At least from your point of view, because you have length and, you have width and height there from your vantage point, okay? You have width, which is sideways, right? And height, which is the thickness of the string. So you have 2 dimensions. They call this one-dimensional. That's the problem.
Well, they don't call that one dimensional.
Well, they call it because
what
they're going to call
it. It's the other way around. They take a number line and call that a string, which is what people think is.
But they tell you that it's one-dimensional.
Well, it is because it's a one. But what they're saying is we have one number line.
Yeah.
The one-dimensional one number line, and we're going to call that a string. No, don't call it a string. String makes it sound too.
Don't call it a dimension.
Yeah, don't call it a dimension either.
I mean, this is the issue. They call it a dimension when it's not even 1D.
And physical and dimension makes it sound real.
But look at the example they give you, a hose. And they say, you look at the hose from far away, it's 1D. No, it's 2D from anywhere in the world that you can see it. If you can see it from the other side of the universe, it's still 2D. At least, if not 3D. But for sure 2D. It's not 1D, but they say what you're staring at is what is 1D, and that's where they make the error. And they say, if it's 1D, it's only length, and if it's length, it's a string. So that's how they make the transition.
Real quick, is there anything in that exists that isn't exactly 3-dimensional?
No.
Okay.
3D, everything.
Everything that exists is exactly 3-dimensional.
Exactly. 2D does not exist. 2D, you can think of it this way, a square is the face of a cube. So you're staring at the square, let's say you just stare and you can't see the rest of the cube behind it. We say that's a square, that's a 2D object,
but
that's what you're seeing.
But essentially what we do is we're saying, well, we don't need the third dimension, so we're just going to do without it. Because they do that in programming also, where they just basically throw away the z-axis because they're like, okay, for this object, we don't need it, so it's 2-dimensional. Only because we don't need the third one. And these guys took it a step further. They're like, this is 1-dimensional because we don't need the other two.
Yeah.
We don't need more, so let's just call it 1-dimensional.
But
there's no such thing as a 1-dimensional or a 2-dimensional. Right, it's just how many dimensions do we need for that object?
Yeah, but what I'm worried about is what these people are saying, because they're saying that this is 1 dimension. Because you're seeing it from far away and you say, well, that's just 1 dimension. No, this is 2 dimension. If you can see it, it's at least 2D. Yeah. And they think that a line, in geometry, they say a line is 1D. No, a line is 2D. Yeah. And a point is 2D.
A number line is 1-dimensional.
Even the
length,
because the line is the dimension. Not the numbers. The numbers are concepts.
You know something that is 1-dimensional? Length.
No, the minds of these people. That's what
Width is one dimension.
Yeah. Okay, so here we have these people are saying that the hose is 1D, and you can see it's at least 2D, but they call it the 1D hose. They have the little ant crawling around it, and they say the ant is going around in 2 dimensions. No, that's not dimension. Those are number lines that they're talking about. The ant only lives in 3D world. Okay, so but these people call that 2 dimensions. And there you can see on the bottom left an example of compactification. At large distances, a 2-dimensional surface with one circular dimension looks one-dimensional. No, that's
looks
not.
One dimensional.
Now, is that one-dimensional? It looks like 2-dimensional still to me. It looks one-dimensional.
That's an oxymoron. Looks one-dimensional. What do you mean looks one-dimensional? If it's one-dimensional, I can't look it, can I?
But this is the issue. They point to a 2-dimensional object. You're staring at it. You drew it, on the board, and they say that's 1D.
I'm gonna say that to my skinny buddy next time. You look one-dimensional, bro. You gotta eat something. You look one-dimensional.
Okay, so this is what the strings look like.
What?
Do they look like one-dimensional things? Whatever.
They look like what?
At least I would say
bubbles.
Well, no, because you're supposed to see them as just a 2-dimensional, one-dimensional thingy.
Is it okay? Is it 2 or 1? Come on.
Yeah. Well, they're supposed to. They're saying that these wigglings are what creates. So what you're looking at is the particles, and they say a particle is really a vibrating one-dimensional string. But I see that it's got 2 dimensions. Otherwise, I wouldn't see it, right? Yeah. If it's one-dimensional, we wouldn't see it at all, right? And so, they have it vibrating back and forth. And they say the different vibrations are different particles.
You don't understand. This is for dramatic effect, but yeah. They don't actually look like that.
Yeah, but see, they're trying to illustrate something which is unillustrated. It's unimaginable, let alone illustratable. You cannot imagine
for the dummies like us, boss. We're a little slow. They got to show us the flashy lights.
Okay, let me tell you what the story is. In the old days, people believed that you die and your soul goes to heaven.
What?
Right? What? Your soul goes to heaven, right?
Okay, yeah, but this
comes out.
Tangent. Where are you going with this?
Okay, you'll see where I'm going with it. You'll see where I'm going with this. Okay, so here's.
Don't tell me the government lied about that too. I want to go to heaven.
Okay, so here are the people going to heaven. This is the way it used to be. Okay,
it was
normal stuff.
God closed the gates or what?
Yeah, people would die, all over the earth, and they would slowly, seep into heaven. And today we have something different, or something similar, really, almost exactly alike. And it's this fellow Brian Cox, and he says that all these gravitons that produce gravity, they go to some unseen dimensions. And this is what it looks like, I guess. Gravitons going into this 4-dimensional world. Okay, and this is what Mr. Cox says. He says, look, the reason gravitons disappear is that they vanish into a place beyond our reality, into some sort of extra dimension. There can be extra hidden, unseen dimensions. It sounds ridiculous, and it is impossible to picture. But theoretically, it is possible. That's what he said. This is a so-called physicist, okay? And it's also possible that gravitons, the particles of gravity, can spend most of their time in those extra dimensions. Okay, so gravitons
most of their time.
Yeah, so
like they're people.
Yeah, they spend all their time, going to this 4-dimensional heaven.
What?
It used to be the souls that went there. Now it's the graviton.
Come on, you wrote that.
So these guys haven't invented anything new. They're just replacing souls with gravitons. So the reason we don't see the gravitons is they're over there in the unseen, undetectable dimensions.
I got a question. Is the rope one-dimensional?
No, absolutely not. 3D. Everything that exists is 3D. Your rope exists, you could say, because it stands between 2 objects, and for that we have to define exactly what the word exists means and what an object is.
It's even 3D as far as imagining the structure.
Yeah, well, 3D. I mean, that's what a rope is. That's 3D, and we're not kidding anyway. We're not saying this is 1D or 2D. This is 3D. Okay, and we're saying the rope is 3D. Okay, the rope is 3D. It's just so thin, so tiny that we cannot see or detect it, and it's untouchable, unseeable. And you say, Bill, you're introducing ghosts and goblins. No, we're saying that an
Ghosts and
object.
Goblins is saying 1D. That's Ghosts and Goblins.
We're saying that a rope is this. This is a rope, and it's 3D, and that's what we're saying it is. 3D, no problem there. Okay, hopefully. And you say, well, we can't touch it or see it. Then you're introducing, fantasy. No, because an object is not that which you can see or touch. An object is that which has shape, and hopefully this has shape. So we met the condition for an object. Now for existence, we need to have it location in the universe with respect to the rest of the matter in the universe, and a rope does have that. So yes, the rope exists under that definition. And that's just to produce the hypothesis. A hypothesis is something you take at face value in order to understand the theory founded upon it.
As far as the Cox guy, right?
Yeah. It kept you rolling, huh?
Well, yeah, because it's just amazing to me how physicists are still so full of...
Don't call them physicists. Well, please.
Whatever you want to call them. Mathematicians.
Yeah, that's better.
Even they who dedicate their lives to science, or at least try to, are so filled with like poetry, metaphor, a superstition. It's no wonder that there's still religion around.
Well, because a lot of the people out there, they want real answers. They want to know why this pencil falls to the floor. That's all we need to answer. They haven't been able to answer the answer. They haven't been able to answer that in 10,000 years.
That's weird.
And how difficult can this be? Here we have...
I mean, it's difficult.
Oh, it is?
It is.
No, the only reason it's difficult, you cannot see the mediators. And that's why we're saying the mediators are the ropes.
It's easy to you because you already got the answer. If you know the joke, obviously it's easy. But until you know it, it's hard.
Yeah. Anyways, here's the rundown of conclusions for today. We have it. Mathviz, mathematics, has 3 branches: general relativity, quantum mechanics, and string theory. Relativists confess that they can't even imagine the 4D, let alone see it. Okay, so that's out of the way.
I can imagine a lot of 4Ds.
Okay, well, but they're talking about length, width, and height, and time, and they're thinking about the hypersphere or the hypercube, and they say you cannot imagine it. Okay, great. So that rules the 4D out. But then we have quantum mechanics that doesn't deal with dimensions at all, right? And then string theory proposes 10, 11, and 26 dimensions. You take your pick, okay? Whichever theory you subscribe to. String theorists admit that they can't see these dimensions, right? String dimensions are curled up and compacted, okay? So they're curled up into little curlicues, and that's why you can't see them. And mathematicians allege that quantum mechanics gravitons hide in unseen, undetectable dimensions.
And that's another way that they use the word dimension. In fact, that one's used far more often in fiction and movies and such. Dimension, what it really means in like just day to day, doesn't really mean length, width, and height. What it means is an alternate reality.
Yeah,
that's how they use that's how they use the word there, where they say that graviton is in another dimension. They're not even talking about length, width, height, temperature, or time. They're just saying it's in a different reality. So that's extra confusing when they use the word dimension.
And there's something.
Why do they use the dimension in both terms when we're supposed to be doing science here? Like, pick one. They can't be both.
That's one issue. The other issue is that you notice that because they cannot answer any question, they cannot answer gravity specifically, they put all these dimensions beyond your grasp or beyond your understanding. They say, well, we don't understand it. It's out there. All the gravitons go to this heaven that we can't see, this 4D heaven. And so they put it beyond your reach. Yeah. So you say, oh, that's so awesome.
Oh, they know so much. They're so wise.
Yeah, because they put it beyond your reach, your understanding. They put it beyond your imagination.
Thank pigs for these guys, because, man, we're too dumb to understand this 26 dimension thing. Jeez.
Okay, folks, let's move on to some of the questions, the comments people made. One fellow made this comment.
You're not going to make fun of him, are you, Buzz?
No, never. Okay? Here we have this fellow. He says, take a big round ball of wood and imagine its space of the, in other words, that the spaces of the known universe. It's as big as the universe, right? Okay. Now, string physical presence through it by making holes in caverns. Okay, so he's going to string holes through it. He's going to string, poke through it, right? Okay. And he says he's going to poke physical presence with this, okay?
You lost me with that one.
Okay. Yeah, the wood represents space. I thought it represented his brain, okay? And the spaces represent presence.
What's
okay,
presence?
Well, I don't know what presence is, but let's continue. Both volumes can be calculated. The difference is that one has density and the other doesn't. Volume has shape.
What is he talking about? What?
Bartender, I'd like to have whatever he had.
What? No, I wish I knew. I wish I knew enough. What is
Poor
presence?
people.
Is he talking about like consciousness?
I don't know.
Like
Physical
presence?
presence? I don't know.
Or
He,
kind of
he must,
presence?
he must have seen a ghost. I don't move the curtain.
Shit. What?
But here we have someone even more intelligent. He says, he says, so a black hole is basically thick bunch of ropes. No, it's not a thick bunch of ropes. Here we say there is no such thing as a black hole. So we say black hole is nonsense.
Hold on.
Yeah.
You do explain the same, let's say, what?
No, not with ropes.
Phenomena.
No, I'm going to explain that in a minute. So
because they use black holes to explain the weird matter going through I don't want to say singularity but point.
well, let's show how the idea, how this notion
Where
of
did a black hole come from?
let's start
use
there.
it to explain
Well,
certain things?
I'll go through that whole thing.
Explain?
Give me a second here. I'll go through it. So this is Cygnus X1. This was the first black hole supposedly detected by humans. First, it was. It's important to understand that the notion of black hole came out of mathematics. Okay, we have Schwarzschild. He was the first guy, German guy, who came up with a notion, and it was followed through by Chandrasekhar, and then eventually by Stephen Hawking and Roger Penrose. Okay, so these people are the people who really introduced black holes into the general population, and this was our first detection. Okay, of the black hole, Cygnus X1. Here it is. They saw this star, okay, in this constellation, and this star was moving in circles quite rapidly around nothing. So they try to answer, why is this happening? The astronomers, right? And they say, oh, we know, it's a black hole, which was invented by Schwarzschild. In fact, maybe you can even go back in time, find a British guy who already had come up with this notion of a star so big that would collapse to a point. So they say there's a little point there, very massive point in the center of that circumference, in the center of that orbit of that star that we cannot see. So what did they do? They put it in there by hand. Okay, and so they put the black hole in there and they say, see, this is why that star goes around, because there's a black hole somewhere in there that's turning it around. We can't see the black hole because it's black, right? No light can come out of it. And so this is how they proved that this star was actually, going around a black hole. Okay, so this is how it all began in a few decades ago, really, 4 or 5 decades ago. I think this was in the 70s. Okay, so this was our first detection of a black hole. They saw a star moving around a center of gravity, in a circle.
Well, it's the first thing you think.
Well, yeah, if there's something there, but yeah, are we gonna put an angel there? If I put an angel, say, well, that's baloney. Angels don't exist, but you accept that a black hole exists, which is what? Zero dimensional. Okay, let's make sure we understand that a black hole has no matter whatsoever. What is mass? It's the quantity of matter. Matter is crushed out of existence in a black hole. Black hole is 0D, no size, no nothing. It's the definition of nothing. And you're saying that a star goes around nothing? That's what they're saying. But they're saying it goes around mass, not around nothing.
It goes around heavy nothing.
And so here it is. Let's listen to Mr. Stephen Hawking again. Chandrasekhar calculated that a cold star of more than about 1.5 times the mass of the sun would not be able to support itself against its own gravity. Would it collapse to infinite density? Infinite density meaning 0D. Really, that's what they mean. It approaches zero. But they always say it's infinitesimal, meaning it approaches, never gets there. But it does, because it crushes all matter out of existence. Eddington was shocked by that implication. Eddington was Chandrasekhar's boss at the time. And he refused to believe Chandrasekhar's result. Eddington thought it was simply not possible that a star could collapse to a point. Zero-dimensional point, remember? Points are 0D. Einstein himself wrote a paper, what did Einstein say? In which he claimed that stars would not shrink to zero size. Now, what is zero size? Zero size is nothing. It's space. It's vacuum. That's what zero size is. That's what a black hole is. Zero size. There's nothing there. All matter crushed out of existence. Mass is the quantity of matter. There is no matter because it's been crushed out of existence. It shouldn't have any mass either.
Well, no, the
Okay?
matter gets destroyed, but the mass is still.
Well, but it can't be because the definition of mass is quantity of matter.
Yeah, but
So we got a circular argument.
wait. What's the definition of mass is quantity of matter?
Yeah.
So
Well, that's one definition.
But
They have
then,
several.
but then once the matter is destroyed,
Yeah.
then the definition becomes quantity of.
Quantity. Oh,
That's
yeah,
that's,
quantity.
that's how that works.
All we have is quantity.
Yeah, quantity.
But
of.
anyways, then he continues, says Chandrasekhar was given the Nobel Prize for his calculation that a star collapses to zero size, nothing,
Genius.
no dimensions, no nothing.
Genius.
And they call that a black hole, a nothing. Okay, so that's the starting point. That's what you should understand first. Okay, so how do we explain black holes? This is a black hole according to rope model. Okay, here we start with this. We see a charged particle, as it's called. We'll call it a charged ball. Means it's got it has some electricity in it. Okay, so it's charged, and we have a magnetic field, whatever a magnetic field is, raining down upon it. And what it will do, you can reproduce this in the lab, it will move this particle in circles around itself. Okay, like that, like you see there. Now, is there a black hole in the middle of that orbit? The answer is no.
Well, can I stop you real quick?
Yeah.
So you're saying gravity isn't the only thing that would make a planet go in circles.
Exactly.
Magnetism could do that as well.
Correct.
And they completely discounted magnetism.
Right. So you can see a magnetic field does make a charged particle move around in circles. This has been known for a long time, since the 19th century. This is nothing new that I'm presenting here, okay?
Do you think that they just didn't think about it, or they're like,
no, because
there's no magnetic field big enough?
The only thing a mathematician considers is mass and gravity. They never talk about electricity, about magnetism.
Is a thing.
They know that a galaxy has magnetism. In fact, that's the next point I want to show. Here's a galaxy, okay?
Yeah.
Okay, this is more or less what a galaxy looks like, and it's really kind of fast here. You know, a galaxy moves very, very, very slowly, okay? And here's a galaxy that is moving a charged object, such as a star, around in circles. Okay, we have the magnetic field of the galaxy, and it's raining down on a poor little star that for some reason is in a region where the magnetic field is strong, and it moves it around in circles without there being a black hole in the center of that orbit. You do not need a black hole because there is no such thing as a black hole that mathematicians have been looking for. They're only looking at mass, and this is not a mass-related phenomenon. This is a phenomenon related exclusively to the magnetic field of the galaxy. Okay, and so it moves a charged object such as all stars are. All stars have a magnetic field, and so it's going to affect the galactic magnetic field is going to move the magnetic object, this little charged particle, is going to move it around in circles without there being any black hole whatsoever. You do not need a black hole to explain this phenomenon known as a black hole, which according to their own definitions and calculations is zero-dimensional.
Man, life is crazy, man.
So we have a totally different explanation for what a black hole is. There's no such monster. Zero-dimensional, infinite density, infinite mass. No such monster.
It's crazy how much weird motions are going on all at the same time. But you'd think that they'd have some. I guess that's what sucks when so-called scientists kind of boil it down to not only things that don't make sense, but things that even they don't understand, but also things that, because once something can't be understood, then it takes all the fun out of it.
Yeah, and so
that's why everyone gets out of the whole discussion.
But you know what the punchline, what the corollary to that is that Hollywood doesn't make fantasy movies anymore. They call them documentaries because they get the information from the mathematician, and they say, "Look, we're not cheating."
How many dimensions? 223. Hell yeah, that makes the sun even more mysterious. They'll eat that shit up.
Anything there today?
Is every atom a universe?
Well, I mean, it's that's poetic. That's good.
But not literal.
Yeah, I mean, universe is space and matter. That's what the word universe stands for. It's a concept. There's no so physical object called universe. It includes space, which is a concept, nothing, which serves as a backdrop to the matter, which is interconnected. All the atoms in the universe are physically connected to each other.
I think I know how you'll answer this one, but I want to ask it anyway. Could a galaxy be said to be alive? Or living?
No, because living alive means that it can move in a given direction against gravity.
See, and that's a good answer. See what I like about that answer, what I love about that answer, which you don't hear very often in YouTube discussions. In fact, I was listening to one the other day, like 2 days ago, that drove me crazy because they don't do what you did. What you just did, implicitly, you had a definition in your head and you just followed the definition. But normally people don't do that.
You follow the definition.
See, what you just said was
I promise I will not bang you over the head.
Essentially what you said is, well, according to the definition I gave, it would not be one by definition, because the definition I gave for alive, the word you use goes against gravity, and it doesn't, so it doesn't. So
just follow your definition.
But what other people say, well, depends on what you mean by alive.
Yeah, no, if you don't like my definitions, no problem. You have the option of redefining the word and defending.
It's always a yes.
Your definition.
I guess the best way to clarify that is it's always a yes or no. It depends on what you mean by alive.
Yeah, but then again, all you have to do is define life, and we'll know. We'll all be
maybes.
On the same page.
There's no maybes about
this. And hopefully you don't say it's what reproduces and what grows and none of that, because not everything. My grandmother didn't reproduce at the age of 80, so I don't think she was alive. Okay, anything else out there?
A lot of questions I don't get, but
okay, see what you get.
a lot of them are also rhetorical, so it's hard to separate those.
Yeah.
That's it. If I don't get them, you can get them, I guess, afterwards.
Okay, folks, we'll call it a day, and we'll